Hello, my name is Robert Carniero, and I'm going to show you how to install the Glades software on Linux. So, first things first, let's go to the GitHub repository. You'll notice our GitHub organization is github.com/Gatik. Gatik is our umbrella organization, parent organization that has all of our libraries and programs. For instance, Glades. And you can see this is our contract address to verify. We also have this shmedb library, which is the base library for all of our other code. The name is a bit of a misnomer. It's mostly a networking library. It does have some basic database functionality, and we will expand on that in the future, the database functionality. We also have this library right here, GFX++ or Graphics++, and you can see that all these libraries are in C++, and you don't really have to worry about the specifics. We have some very nice scripts to help download, install, run all of this for you. So the very first thing is we're going to go to Gatik installer. It's pinned at the top of our organization, or if for some reason you do not see it on our organization page, you can in the search bar type install. This install search bar will come up with Gatik installer. It's the only thing that we have that has the word install in it. So I'm going to click Gatik installer. Our repository Gatik installer has a bunch of .sh files, also known as shell files. These shell files are just a bunch of Linux commands in one spot. So instead of having to type and run all these Linux commands manually, you can just run these files and it will handle a lot of these more complex tasks for you. The first thing we do when we visit any repository is that we look at the README. Hence, GitHub putting the README right here on the front page. And we can see this is a pretty short README. There's really not a lot here. It's a pretty simple install. So let's give it a go. So our repositories, our code, relies on this dev directory inside of our home directory. This little squiggle right here is all it means is home. So it'll put you right next to your my documents, my pictures when we create the dev directory, and it's automatically created when we run this first command. So let's run this first command, okay? The only thing is, before you run this command, make sure that you have your SSH keys generated on your machine and uploaded to your GitHub in your GitHub settings. I'm not going to explain how to create or upload your SSH keys. There are many tutorials on how to do this. So let's assume you have your SSH keys already set up. We're going to do git clone this repository into this directory. And because we are using the SSH version, it'll allow us to easily upload and download data between the machine and GitHub very seamlessly. So I copied this line, and you can just paste it in your Linux terminal. Doesn't matter where. You'll notice it downloaded and created some folders. So for instance, this dev folder I mentioned, just in your normal user directory, it created this Gatik installer file. Gatik installer, you'll notice, has the files that we saw before right here, these shell files. That was step 1. Clone the repository. Very easy. Step 2, there's an easy way to do step 2 and a hard way to do step 2. Looking at the hard way, just to explain what's going on, we create aliases to run these files for us. So that all we have to do is type in these commands and it will run the files for us. But the hard way is putting all of these in your environment manually, but you could just copy paste under 2A, there's one thing right here, and this will do step 2 for you very easily. So step 2, once again, we're just copying and pasting a line, and you can paste it in any directory in your Linux terminal because, once again, we use this squiggle to refer to our home directory. We can paste this anywhere. I'm going to hit enter, and you'll notice if I look at the end of this bashrc file, you will see that these aliases that we saw before are copied, pasted right into here just from this one command. things like gstatus, gsetup, gsync, right? And in order to use these commands, you either have to close and then reopen your terminal, or you can just type source squiggle / dot bash rc, and this will just refresh that file for us. Step 3, very simple, we just type gsetup. So gsetup, and look, we can see that it auto completes because it's in our bash rc file now. So if I type gsetup, you'll notice that it's going to download, aka clone, all of our other repositories necessary to run our Glades software on Linux. And we can look at the folders that it created right here in the dev folder. We talked about each of these, except Neural Net Creator. What's that? So Neural Net Creator is a runnable program. Before I describe to you libraries are pieces of code that we can basically reference from our different running programs. So this running program is going to use these libraries, aka use this code, in order to allow us to create, manage, run, debug different neural networks. So as you can see, we're flying through these steps. That was step 3. Step 4, we need to install the dependencies for these libraries. If you were to look inside of the Neural Net Creator folder, there is an install file that will tell us what dependencies we need. See this file right here that exists? I'm just going to output it for us for an example. It gives us some instructions, right? But once again, we made some scripts in order to do everything for us. So I mentioned we're going to copy this line. We're going to paste, and this will install all the different packages that we need in order to run our software. And these are some base level simple packages. If you are an experienced Linux developer, you might recognize 90-95% of them. Let me type my password right here. So I already have all of these installed because I run my own software, of course, all the time. However, you might sit here for a few minutes watching some things install. If there's any errors, maybe just install the one package at a time that gives you the error. Okay? And if there's any errors, we will find out on the next step as well. So the next step, gbuild. We just type the word gbuild. And once again, because we put it in our bash rc, it auto completes. Gbuild. So right here, you can see that our C++ code is compiling and linking against the different repositories, the different libraries. Right now, the ShmeiDB networking library just finished. The machine learning library is going. Next, you'll see there's also the graphics right here, compiling. If there's any errors installing your packages before, you might see some things not compiling here. If something is not compiling here, make sure that you installed all of the packages properly from the previous step. In addition, if you think you've installed everything correctly, you are welcome to come to our GitHub, create an issue. We'll take a look and see if we maybe forgot to supply a package. We also have the Discord. If you're having an issue, you can get some real-time help in the Discord, and we can help you build. So I'm building this on a very normal computer. This is probably how long it will take to build it the first time is always the longest. If you are on a very fast computer, it can be very quick. If you are on a Raspberry Pi, for instance, we support Raspberry Pis, this will probably take a lot longer to build on a Raspberry Pi. We support 64-bit and 32-bit machines. Cool, so the neural net creator just finished building as well, the program that utilizes these libraries. And so let's just run one of the other commands, gstatus. Just see the status of everything. So look, we're on master for all these repositories, and we're up to date and everything with everything that's supposed to be downloaded perhaps from what's called upstream, aka the GitHub. And over here it looks like everything compiled correctly, so we should just be able to run it. And look, so following all these commands, we were able to download and build our entire code base. So now, how do we actually run the code? Well, that's a very good question. So we have different branches of code, different versions of code. I'm going to switch to, just to show how to use another command, I'm just going to switch to a staging branch, pants. Once again, I can do gstatus to show that I switched to pants for everything. We have master, fancy, and pants. Master is the most stable. Pants has the newest updates. So typically when I make a change, I'll switch to fancy. It allows us to get some of the newer updates while also being pretty stable. But in this case, pants is fine, just for an example. So we have all these repositories with pants. Because we switched versions, I'm going to do gbuild. You'll notice it'll be a lot faster because we're not compiling the entire code. We're only compiling the difference in the code between this version and master. Although this is not in the README, I think this is important to show you guys perhaps how to switch branches and that we need to rebuild. So I provided an example here. And so everything looks like it compiled and built everything perfectly fine. So let's try to run some stuff, alright? So the first thing we can do is let's look at some unit tests. The unit tests will show us how to run the machine learning in a terminal environment like this, the command line environment like this, and next I'll show you the neural network interface. So I went to the dev folder, right? That's where all of our code lies. GladesML is our repository, and we have this nice unit test folder. We have a file to help us run the unit tests. You see right here, this one file .configure will make a build directory and run cmake and make in it. Very similar to what the scripts that we just did were doing. The scripts that we just ran utilizes these .configure scripts in the different directories. For the unit tests, we're going to build them separately though. So the unit tests, we're going to do sh shell, remember, .configure. This is the name of the file, .configure.sh. So I just ran this file, sh space .configure.sh, and you'll notice it built pretty quickly. Let's navigate to the build directory and type make run. This will run the unit tests utilizing the Glades library. So you can see a neural net running there, another one running there, and a couple other AI output. Let's briefly skim this. We're not going to dissect the whole thing. But basically in these unit tests, we have one neural network that is, right here you can see the structure, basically just built to test the concept of exclusive OR. That is a very nice basic obstacle to test for machine learning. The concept of exclusive OR, that relationship, is very unique compared to things like AND, OR. It's a lot more difficult for the machine learning to learn, so it's a very good first unit test. The next unit test is this iris.data. This is a very popular data set that classifies flowers. There's 3 classifications. as you can see here, iris setosa, iris versicolor, iris virginica. I'm not a scientist, I don't know how to say that, but I'll assume that's a real flower. So yes, right here is a classifier that can classify different flowers based on different features, such as petal length, etc. This is a very popular machine learning data set, so it's a good benchmark if you are creating a software like ours to see how well it runs and how well it can handle the data set. We have another data set here testing the concept of exclusive OR again, but with words such as dog and cat. And we have various other output from different types of AI that are not feed-forward neural networks, such as PCA, aka principal component analysis, as well as, if you know Bayesian probability, there's something called a BayesNet. Works a little different from the feed-forward neural networks. And here are some examples. I'm not going to, once again, talk too specifically about the output, but if you have any questions, you can come to the Glades Discord, ask away. We will try to answer everything we can. So that's just an example of how to run, very simply, the Glades software, but a lot of people like visuals. So let's navigate to our neural net creator folder. So dev neural net creator. I just printed some files here. Once again, you know we have this .configure, right? And that will allow us to build and run the program, but our previous scripts have already done this for us. So we can just navigate to the build directory and do make run. So as you see right here, this program popped up when it did make run, but there's another command you can run it with, make local. They are effectively the same thing, however, make local will disable the networking. The networking allows us to run different machine learning on different computers, as well as technically any other code that we want to run on another computer. This will help us decentralize this work. Often people will only run on one single computer, so make local is suggested. Just less work for your computer. There's no reason to turn on the networking if you're only on one computer. However, if you are on multiple computers, you will need to run make run so that the networking is turned on. We have different options for creating and editing neural networks. And we have some different outputs that the neural network will output that you do not see in the terminal like we did before. Some fancy outputs. And stay tuned in the next video to see what those outputs, those graphs will look like, as well as how to create, edit, change neural networks.